You are muted, sir. Okay, no problem.
I'm 53, exact 53.
Oh, you're exact 53. The rule is working on the right side also. Very good. Now, this is, if I see, I can make it perfectly all right when I actually use the real data. What is real data? All your ages. If you don't trust me, all of you are in a group, you collect your age, type it, calculate the standard deviation, and then you will see for yourself. Now I am 99.73% confident that age will lie within 24 and 53. Now, what is my confidence level? 99.73. How do I get? This is a rule of normal distribution, right? You will be mastering everything. If I collect the sample without error, the whatever finding you obtained for the sample can be applied to your population also. If this data I sincerely collect, I can use this information to conduct my digital marketing to attract black belts in my program. Will it work or not?
Yeah.
Definitely my digital marketing will work. What is the point? Why should I unnecessarily pay for people in the age group of 20? They are not going to join my program. It is only after 3 or 4 years of experience they come to know about Six Sigma and other things. So for your prediction to work very well, you must collect the data without any error. Error always can happen due to measurement. Error always can happen due to sampling. You must get rid of both. You must control both. Keep less of the error and predictions will sound better.
Sir?
Yes.
This in the graph, no, this variance, how we can indicate? Standard deviation we can indicate, no? That normality graph, you bell curve you show, no? Whether variance we can do it? Or
no, variance is actually sigma square. You can use the variance also, but you need to know what the variance speaks. You need to know what the standard deviation speaks. Right? And the variance is difficult to use. Why? Because what is the unit of the data we used here? 39 means 39 years.
Yeah.
40 means 40 years. Yes. 18.3 means?
It is again, it will not be a full value. It will be a partial.
It is 18.3 years square.
Yeah.
So how will you use it? It is difficult for us. So you take the square root, you get the number 4.27. Again, the number is in the same unit, 4.27 years. So centimeter, millimeter, kilometer, grams, it's easy to work. But gram square, we can't understand easily, isn't it? So variance, that's why we generally prefer standard deviation to make our predictions. Right.
Sir,
and now,
sir, before slide, please go to before slide. Sir, how 24.4 and 52.6 arrive? Please explain one side.
Average plus 3 times sigma. An average minus 3 times sigma is the formula to arrive on the numbers. You can try yourself.
Okay.
Average is given, standard deviation is given.
Okay, sir.
Right. What I do is I'll skip this. Right. See, there are two things always. Your process will have a width. Your customer, we call it process width. The width of the process is described using the control limit. Width of the process is described using the control limit. Why do I consider control limit as the process width? Because when I go up to control limit, 99.73% of the population can be understood. Am I right? 99.73% of the population can be understood by going up to control limit. So control limits will help me to understand the width of the process. Do you think customer will also give some specification? Always customer gives specification. 100 plus or minus 5. It means 95 and 105 are the limit. Now 105 is called upper specification limit. 95 is called lower specification limit. If you simply ensure your process width is less than the specification width, your business will be highly successful. You can make your business highly successful if the process width, you make it less than specification width. What is process width? Distance between upper control limit and lower control limit. What is specification width? Distance between upper specification limit and lower specification limit. Who will give the specification limit? Customer. Where from you will get the control limit?
Process.
From the process data. Very good, right? So if you simply make sure process width is less than specification width, it will create pleasure in any business. Everything you produce, you can make it acceptable by your customer. Everything you produce, you can make it acceptable by your customer. On the other hand, if your process width is going to be more than specification width, definitely there will be worries, and definitely there will be challenges. These worries and challenges means there will be rejections at the customer end. There will be rejections at the customer end. And now you can better understand the same thing with this example. Imagine you have a parking area where the width is capital D, and you've got 3 cars. First car is bigger than the parking area size. Will you be able to park this car?
No.
That means your process width is more than specification width. Whenever your process width is more than specification width, failure is sure. If you still try to drive the car and take it inside, your car is definitely going to be damaged, no doubt. Clear? On the other hand, my car size and the parking area are exactly same. It looks I can park it inside. But when I want to open the door, or when I am not in a controlled in a particular day, I make some mistake in the driving, what will happen to my car? Again, there will be a damage. So keeping your process width exactly equal to specification width may also cause failure. But it may look good initially, but in a long run, it will cause failure. On the other hand, when my car is too small compared to the parking area, even when I shake a bit, I drift to the left or right, then also my car smoothly goes inside. I can open the door, isn't it? Everything is possible. Nothing wrong happens to my car. So that means if you keep your process width much smaller compared to the specification width, in spite of your mistakes, your business is going to produce fantastic results. Because there is no one in this world who is perfect. Always there will be some deviations. You must have some room to allow for those deviations in your business process to make it produce defect-free outputs. Logical? Right. And now another example. Imagine you are a pilot, right? You are a pilot, and you can see a Boeing or Airbus here. There are 300 passengers who want to fly with you. I want to test your capability. Will you land the aircraft properly or not? Now your flight is 1,000 miles above the ground. Your flight is 1,000 miles above the ground. You need to land it. And now what? Okay. Now what I want. Okay. All right. So now I'm asking you to land the aircraft. And as usual, you will tell me definitely, sir, I will land the aircraft in the center of the runway only. Am I right?
Right.
Because center of the runway only you must target. Why it is? Because that is the safest point. That is the safest point. That's how the center is helping you. So that is why most of your landings are around the center. I'm showing you few more landings. Few landings are can deviate from the center. Possible or not?
Yes.
Possible. Now it is deviating to the right, and few are deviating to the left, and again few are going on to the right. The right and left will keep on happen always in any business process, and few more landings. When I visualize this, it looks like a bell for me. That is why I told you 95% of the business process or 95% of the data will follow normal distribution. Preferably that is why we want you to collect the data always in a continuous fashion. Don't collect the data in other way, like the discrete data. Avoid using. Use the continuous data, because the bell shape will very frequently form, and then you can make predictions. And now see here, some of your landings are far away from the center. The point which is far away from the center, we named it as control limit. Similarly, the point which is far away from on the left side, this is called lower control limit. As all your passengers in your aircraft, 300 people, they want to see that you are landing in the center of the runway. Isn't it? Because that is more safer for them. But there is a line drawn at the end of the runway indicating what? If you touch the line, that will lead to a crash. The entire plane may get crashed. That is called upper specification limit on the right side. This is called lower specification limit on the left side. Now, this is what? The customer targeted landing point. The average calculated from the data of your landings will tell me your ability. your ability to meet the customer requirement. And then what is this point? The extreme landing point on the right, your upper control limit. The extreme landing point on the left, the lower control limit. The runway ends here, upper specification limit. Runway ends on the left side here, lower specification limit. So the challenge in any business is getting your control limits inside the specification limit. If you get your control limit inside the specification limit, you are playing the game of business very well. There will be only profit. There won't be any loss. But if you play the game in such a way that you place the control limit outside the specification limit, there will be rejections. There will be losses. Clear? Now, do you understand the difference between profit and loss? Keep your control limit inside. USL, LSL, UCL, LCL. Right. So this is what Takuchi also told you. What is that Takuchi told you? Produce everything around the target. Make all your landing in the center. Right. If any turbulence, anything goes wrong, then also you will safely land your plane in the runway. And now there are three pilot I am showing you. One in green color, one in yellow color, one in red color. Now tell me, which pilot would you prefer to fly with? The red or the yellow?
Green.
Green is more safer, right? So average tells you, which group is better always. All right. So customer, your process average will help you to understand whether you are running the process around the customer target or not, right? And then drift will be there in any process, which is unpreferred. Your drift can be understood by measuring variation. How will you measure variation? Using standard deviation. Standard deviation is one measure. And then customer limits are called USL, LSL. Upper specification limit, lower specification limit. If you cross the specification limit, the failure is called external failure. Because when anything you produce out beyond the USL, LSL, customer will reject your product. At the same time, if anything you produce beyond upper control limit and lower control limit, even if customer accepts it, Six Sigma will call it as failure only. Right? According to the rule of normal distribution, almost 100%, that is 99.73% should fall inside control limit. If that is not happening, is it not a failure? That's a failure, isn't it? So you have to understand producing products outside the control limit is also failure. Though it is inside the spec, but producing outside the control limit is a failure, but we call it internal failure. So to understand the average and standard deviation, imagine you want to shoot the center balloon. I'm showing in the screen, right? Center balloon. And you need to position the bullet correctly. Am I right? The bullet, you must hold the gun correctly. So you are holding the gun perfectly. How do you know whether you are holding the gun perfectly or not? By calculating average. You have developed the process. You designed the process. You trained your people. All that you are doing only to see that your bullet hits the target. But training the people is different. Actual performance is different, isn't it? Now, for example, all of you are getting trained properly. But when the exam happens, performance will differ, isn't it? And so first of all, bullet is in the right position. I am shooting it. So it hits the target. But my only doubt is the real performance, will it hit it? That means when I continue to produce products again and again, the second time and third time, so many times, every time I shoot, whether it will hit the target or not. This is what my sigma is telling. So quality is always a function of X bar and sigma. X bar is average, sigma is standard deviation. If average is on the target, quality can happen. And what should be the rule for sigma? It should be small or big? Sigma should be?
Always small.
As small as possible. If it is very small, every time you will be able to shoot the target. So hold the gun correctly and then hit the target consistently. Right? And your business will produce a lot of results. So what is Six Sigma? It's a methodology to reduce defects by reducing variation. It helps you to improve the performance on CTQ. CTQ means critical to quality characteristics. What your customer likes, that is a CTQ. What your customer dislikes, that is also the CTQ. Customer doesn't care about something. that is not a CTQ for you. Clear? What customer likes it, what customer dislikes it, you have to be careful. Customer doesn't bother about something, you also no need to bother about it, right? So that is the meaning of CTQ. There are two methodology you will be learning. One is DMAC, another one is DMAT-B. Your existing products is having a problem, quality issue, use DMAC. But you want to develop new products, use DMAT-B. Now let us understand what is capability or process capability, or what is sigma level. It is the ability of your process to meet the customer's requirement, and as well as the business requirement. So let us consider a small business. The business is online food delivery process. Online food delivery. There are so many companies, right? Nowadays delivering food. Your Swiggy is there, Zomato is there, I think Uber Eats is there, Food Panda is there. So many players. Now, they have written something here in the box. What is that written? 30 minutes delivery, otherwise the food is free. 30 minutes delivery, food is free. It means what? Is there a specification limit? It means every time you deliver the food, food should be delivered within 30 minutes. So what is this 30 minutes now? Is it a control limit or a specification limit? Specification limit.
Specification limit.
Is it an upper specification limit or lower specification limit?
Upper specification limit.
So upper specification limit is 30 minutes. So what is lower specification limit?
0.
Will you be able to deliver food in just 0 minutes?
No. 1.
Some time is required to prepare the food. So we can have some other value, lower specification limit. I'm going to keep my upper specification limit as 30 and lower specification limit as 10 minutes, because some time is required to prepare the food, to pack it. So LSL cannot be 0 practically. So I consider LSL to be 10. So what is the customer targeted or what is the targeted value here? Targeted value is
15.
no.
30
minutes.
30 is
minutes.
30 is USL, 10 is LSL.
20,
The center
20
value,
minutes.
20. 20 plus or minus 10. By all means, your delivery should be within 30 minutes. But the ideal scenario will be 20 minutes. Now you have to design a process. You have to develop a business, or you have to design a delivery process in such a way that every delivery happens around 20 minutes. Clear? Now that responsibility is given to you. Now how many delivery boys you will hire? Now what kind of packaging material you will give? What kind of vehicle you will give it to your delivery boys? How many hotels you will network? This is called process design. Design it in such a way that every delivery can happen around 20 minutes. Every delivery can happen around 20 minutes, right? And if delivering food, every delivery within the specification is called capability. It's called capability or process capability. And now I have visualized the specification limit. USL is 30, LSL is 10. Target is 20. Now the difference between the two is called specification width. How much is the specification width? 20 minutes. All of you understand everything?
Yes, sir.
And now you hired 100 delivery boys. You trained all of them. You gave scooters to all of them. You gave GPS system to all of them. You provided them some good packaging. Everything you have given. And now several thousand hotels you tied up. Why you do all these things? Because that area population is so high. You're expecting a lot of orders to come. You have made all. This is the process design. And now you want to understand how good your process is or how capable your process is. How will you understand? Only when you collect the data. In a day, how many orders are properly accepted? In a day, how many orders are getting rejected? If so many orders are getting rejected because of the late delivery, what will you do? You will either increase the delivery boys or you will increase the hotel, right? Number of hotels, isn't it? So that you need to do. And now you collected data from the process and then your data reveals like this. Now this is a kind of histogram. That histogram when you collect, and now the delivery time is a continuous data or discrete data?
Continuous data.
It will exhibit normality. Delivery time will exhibit normality, and that is what you are seeing here. And now with the sample data collected, you found that the sample average is called the X bar. Sample average is found to be 20. What is the targeted delivery time? That is also 20.
20.
What is the sample average? That is also 20. Are you holding the gun correctly? You are holding the gun correctly. You have selected right number of people. You tied up with the right number of hotels. All the facilities you have provided are perfectly all right. How do you know? The average is 20. But still there will be imbalance. Somebody will take leave. Somebody, the motorbike will get punctured. Some of the GPS system will take them to a wrong place. All these things will happen or not?
Yeah.
In order to understand, you calculate standard deviation using the same data. If everything happens as per the training, as per the design, there are no worries at all. But it won't happen that way. Standard deviation is found to be 3.33. Now, standard deviation is calculated. How is it helpful? Upper control limit. What is the formula for upper control limit? Center plus 3 sigma. Center is how much? 20. Sigma is how much? 3.33. 3 sigma is how much? 10. So 20 plus 10 is how much? 30.
Yeah.
Upper control limit is 30 and lower control limit is 10. Now, what is your rule of normal distribution? 99.73% of your data should lie inside control limit. If the data is collected without error, 99.73% of the delivery will happen within the control limit. Am I right?
Yeah.
Yes.
If data is collected without committing error, 99.73% of the delivery will happen within control limit. Now I want to understand how is my process. For that, I already learned that I should compare specification width with the process width. So that is what I am doing. I am overlapping specification width and process width. What is the specification width? 20. What is the process width? That is also 20. My car is exactly equal to the parking area. My car is exactly equal to the parking area. As of now, it looks good. But something goes wrong, seriously, in the future, the results, will get spoiled. Am I right? That is the understanding. So now, as of now, it is sounding good. And now, when you keep this kind of situation, you know what will happen? The control limit will overlap with specification limit. When this happens, specification width equal to process width, control limit will overlap with the specification limit. When control limit overlap with the specification limit, all the rules applicable to control limit will be applicable to specification limit also. Now that means 99.73% of the deliveries are going to be within the specification limit. Am I right? Today, your company is making 1,000 deliveries every single day. Today, how many deliveries your company is making? 1,000 deliveries. So how many deliveries are accepted to be are expected to be accepted by the customer? 99.73%. 99.73% of the deliveries are expected to be within the spec. Customer will accept. Now tell me, what is 99.73% of 1,000?
997.
997 deliveries out of 1,000 will be accepted by the customer. They are ready to pay the money. But 3 deliveries, the order will be cancelled. Why? Food has not arrived. Food has not arrived. For some reason, the order is cancelled. Your company is losing the money. What is the chance of your company losing the money? 0.27%. What is the chance of your company making money? 99.3%. Now the business is going good or bad?
Not good. Too much good.
Yeah, very good. It's going fantastically. 99.73% is the success rate. When everything you are doing is good, what will happen? Your business will improve. 1,000 people are ordering every single day. All of a sudden, within a week, you started receiving 10,000 orders. What happened? 1,000 orders a single day suddenly become 10,000 orders a single day. Do you still will find your business capable of handling the orders?
No.
No, sir. The process will.
No.
All that you designed is suitable only for 1,000 orders a day. But all of a sudden, because of your best services, 10,000 people ordered on a single day. But you still have the same thing. As a result, you will lose all your capability. Instead of gaining your name, you yourself will damage your name, because now the failures will be more than the success. All of you are able to understand what I'm telling now?
Yeah.
So this capability is not enough. The success rate of 99.73 is not enough. But 99.73, looking at the number, it really looks great because it is closer to 100. But considering the real-time scenario, if my business improves, obviously, it will damage my name. So there is a need to improve my business process further. All of you are with me on the statement? There is a clear need to improve
Yes.
my business further. You do whatever, whether you want to hire more people, or you want to give them the better scooters, or you wanted to give them a better GPS system, do whatever, or conduct a training. Do everything. What I don't want to see is, I don't want to see my control limit going beyond specification limit. Am I right? I don't want to see my control limit going beyond specification limit. My control limit can move out when my center is moving. Am I right?
Yeah.
When the center is moving to the right, my upper control limit will cross the upper specification limit. My center is moving to the left, my lower control limit will move to the lower specification limit. In a food delivery, left side is not a problem. Left side is not a problem, isn't it? Though we have a limit, that's not a problem. But if you are producing a component where you are dealing with the dimension, you are dealing with surface finish, you are dealing with the hardness, this will be a problem both sides. And one problem we understood, center can move. Another problem is, if the standard deviation increases, center average should not move. Standard deviation, if it increases further, what will happen to the control limit? Will it go further on the right side? Because what is the formula for control limit? Average plus 3 sigma. If sigma increases, average plus 3 sigma will move to the right side. Your control limit will move beyond specification limit. So two ways failure can happen. Average, if it is not on the targeted point, and standard deviation, if it increases, the spread will increase. As a result, my control limit will go away, right? And now I want to understand what is the sigma level of this process. The sigma level of this process is 3 sigma. Why do I call it 3 sigma? Now tell me, yesterday I made a statement. If you center your process at a distance of 6 sigma units from the customer specified limit, your process is called 6 sigma. That is the exact statement I made yesterday. Now tell me where you have centered your process. At the green color line, am I right?
Yeah.
Yes.
And what is the nearest customer specified limit? It is the red color line, am I right? The red color line is the upper specification limit. Now, one of you, can you tell me the distance between the upper specification limit and the process center? How much it is equal to?
3 sigma.
3 sigma.
Since the control limit is overlapping, you can clearly tell me it is 3 sigma. So this process is called a 3 sigma process. A 3 sigma process assures you a success rate of 99.73. This success rate, I very well know, I will apply only for short term. Today it is sounding good, but tomorrow as the demand increases, the 99.73 will no more be valid. Am I right? 99.73 valid only to the current conditions, current level of demand. If anything changes, my equipment deteriorates or the order increases, anything happens, my 99.73 will fall down, my name will be damaged. So 3 sigma process is not a fit process in considering a long-term success. Am I right? 3 sigma is not going to be helpful in the long run. And this 3 sigma process, I will give a nickname here. Look at the shape of the normal distribution curve. Does it look like a head of the elephant? So I am going to call it an elephant process. Why do I call it an elephant process? You must realize the fact that you have put a very big animal in a small room. A big car, you have parked in a small parking area. Can you do like that? Your car is going to be scratched. Your car is going to be damaged. Even for small mistakes, there will be serious damages. Do you want it to happen? No. Only to understand, I am showing the elephant here. Don't try to lock an elephant in a small area. If at all you wanted to control it, give it a comfortable area so that it can also move around, still obey you. Otherwise, your business process will know, will throw away your control limit. Don't do that. And so
Sir?
what is, yes?
Sir, this from the mean line, you have taken to the right side, no, that USL,
Yeah.
and it was told as a 3 sigma process. Just to understand whether can we consider use LCL and UCL, both we should consider, or only one side we should consider?
No, both you can consider. See, always, you must center your process, correctly. When you center your process correctly, for example, the previous slide, center the correctly. Right side you measure, it is 3 sigma. Left side you measure, it is 3 sigma.
Okay.
Always center. See, intention should be clear. First of all, you want to help somebody, your intention should be really to help him.
Yeah.
Then only you help him, right? And
yeah,
the intention is getting reflected in the center. So center of your process, should be always on the target. If the center
yes,
itself is deviated, your first goal is move the center.
okay.
Right?
Okay. But in this case, so there was only the time was only one unilateral, no, sir. Like 30 minutes was a unilateral.
Correct.
No.
Correct.
So whether we should take mean as a lesser, like 15, we should take mean, or how it is?
No. That means your failure is only on one side.
Okay.
Failure is only on one side. The left side, there is no failure. The 0.27 is completely on the right side.
Yeah.
The 0.27% of failure chance is completely on the right side. So we will be measuring the risk only on the right side or only on one side. We call it one-tailed test. So it depends on the kind of product and service. So in this case, it is one-tailed only.
Okay.
We will discuss that. And now, on the other hand, so I understand the need to improve my process. So I improved it. Probably I trained my people, I hired more people, and then, I changed a lot of stuff. As a result, I am able to control my center. Central is still on the target. At the same time, my standard deviation, I reduced it to half of it. Earlier, how much it was my standard deviation? 3.33. Now it is 1.6x. How it happened? I made changes in the process. I networked with more hotels. I increased the delivery boys. The packing time has been reduced. Do you understand how the improvement happens? I do all these things, standard deviation comes down. As the standard deviation comes down, it is an indication that your process is improved. If standard deviation doesn't come down again, you made changes, but improvement is not happening in real time, right? But here it happened. And now recalculate the control limit. 3 sigma is how much now? 1.66 into 3 will be closer to 5. So it is 5. 20 will become 20 is center. Upper control limit will be 25. Can you now understand your control limit is pushed inside? Pushing the control limit inside towards the center is called process improvement statistically. Statistically, process improvement means control limit will get pushed inside. If control limit is not moving inside, you have made changes, but changes are not helpful, right? Similarly, on the left side, lower control limit is 15 and 10. And now, within control limit, what percentage of the points will lie? What is your learning? Within control limit.
99.7.
99.73. Within control limit. If the data is collected without error, the same rule can be applied to the population also. If 99.73 can lie within control limit, much more bigger number can lie within specification limit. Is my statement correct?
Yes.
99.73 can lie within control limit. It simply means more than 99.73 can lie inside specification limit. I'll draw the line for you. Oh God. So this is 99.73. This line, all of you can see the line. Now this line will be longer. So this is going to be more than 99.73. Am I right?
Yes.
Right. This is found to be statistically found to be 99.999. This is statistically found to be 99.999. That means when my company is making 1,000 deliveries, what is 99.999% of 1,000?
It is nearly
9999.
1,000.
Almost all 1,000 deliveries will happen within the time. Am I right?
Yes.
And now seeing my performance, customer has increased my order. Now I am getting 10,000 deliveries a day. Now what is 99.999% of 10,000?
Again,
9,999.
again 10,000. Yeah.
Again, it will be 10,000, right? So that
Yeah.
means you have given no very fewer chance for the failure. What is the chance for a failure to occur? 0.00001,
0.00001.
right? So such a very low chance exists for the failure, and that's how you are making your products defect free. That's how no your process is enabled to produce defect free output. And now this process is found to be doubly capable. Why do I call it doubly capable? The specification width is 20, but the process width is only half of it. You can understand something like this. If you give 20 rupees pocket money to your child spends only 10 rupee. Now the remaining 10 rupee goes into the saving. Will that saving help you in the future?
Yeah.
Definitely. Same way. Customer has given you a tolerance of this much. How much? Plus or minus 10. But how much you are using? You are using only plus or minus 5. The balance 5 minutes you saved will help you in the future deviation. And it is statistically understood that if any deterioration happens, anything goes wrong in any organization, control limit will move out. Control limit will move out. Let us imagine something goes wrong in your business. So control limit is moving out. And statistically, it is assumed that always the movement is 1.5 sigma. The movement is 1.5 sigma. Do you still find some tolerance again available as a question? Yes or no?
Yeah.
Do you find some again? Even see, this is even after deterioration. After deterioration, something goes wrong. Even after something goes wrong, some of your delivery boys are not coming. Then also your process is found to be still capable, because then also your control limit is found to be well inside the specification limit. That's how you are making defects or failure a rare event. This process is called doubly capable process. Statistically, what is the distance of the center from one of the nearest specification limit? What is the distance? This distance? Can somebody tell me?
6 sigma.
Yes. That's why the process is called a 6 sigma process. The success rate of 6 sigma process is 99.999. All of you understand? All of you understand how the success
Yes.
rate increases? Right. And since you pushed the control limit towards the center, how you pushed it? You reduce the standard deviation. When you reduce the standard deviation, everything will be around the center. If everything is around the center, your curve, normal distribution curve, will grow taller in the center. So now you converted an elephant into a giraffe. Seeing a giraffe as a curve in your normal distribution is an indication that you improved your process. So this process is called a 6 sigma process that assures a result of 99.999. Is that clear?
Yes.
Same way you can apply the learning in any business process. For example, if it is a